Let's talk about the best time to buy this stock. Output will be the prices, array of prices. Let's suppose we have an array 7, 1, 5, 3, 6 and 4. And here what we have to do is we have to maximize the profit. Okay. And a single day to buy one stock. The different day in future to sell that stock. So this is the thing, the future the stock, and output will be the maximum profit. In this case, I suppose in this case is I have an array 7, 1, 5, 3, 6, 4. Okay, so here the output should be 7. Let's go with the 7. Let's suppose I had bought something on a 7, and since 7 is the largest in this, okay, so if 7 goes with 1, it will be -6. Okay, if 7 goes with 5, it will be -2. If 7 goes with 3, it will be minus. So I think that 7 will get excluded. Okay. And then 1 come into the picture. 1 goes with the 5, it will be +4. Okay, and the 1 goes with the 3, it will be 2. So 4 is greater than 2, so it will be always 4. So same way 3 into 3 to 1 to 6, 1 to 6, it will be 5. So 5 is greater than 4, it will be 5. So this with output, real output will be 5. Now let's talk about the brute force. So about the brute force. Okay, so the brute force, what we are doing, we are just creating a for loop of I is equal to 0. I is less than equal to n. Let's say the n is the length of this prices. Okay, length. Okay, and till I plus plus. This is the first loop where we are iterating, because we have to compare, right? Because we had compared with everything. So, and then another loop will be, what will be j. J will be I plus 1, because we are comparing with the +1 character, and then it will be j will be less than equal to n, and j plus plus. Okay, so here what we are just creating int profit is equal to p of j minus p of I. Here check will be this, I don't want any negative thing. So if p is greater than 0, then maximum profit will be math dot max of max p and p, and then the return will be maximum profit. This is my brute force approach. Here what will happen, the complexity will be O of n square, because I have a 2 for loop, and then the space complexity will be 1 constant only. Now move to the optimal approach. Similarly, we'll moving to the optimal approach. Okay, so optimal approach will be having a check, because we can track a minimum price. This is the optimal. This is the actually a check on this. What we are doing, we are creating int of minimum price that should be integer dot max. I'm just initializing this to max value. Now I have an int of max p is equal to 0. Now I'm just iterating my array int of prices. Okay, I am just iterating the array. Here I will check if I have any price that is coming as a minimum of p less than. Okay, now I will replace this with my minimum of price. So I'm just like using storing my minimum price. Okay, this is my first check. Here what I had just iterated towards my complete array and check that which is the minimum of it. Okay, and I'm just storing that as a minimum price. Okay. Now what next I will do, the same loop I had created a int profit. Okay, this is the profit that I will compare with max profit. Okay, here what I had taken a p, like the iteration of the p, and to minimum of p, minimum of price. I will just compare these two, and whatever the difference of p with the minimum p will be checked with what? With max profit, and then I will replace the max profit. You can use math.max also to this, but I'm just writing it normally. And then this is the loop what it's doing, and then we'll return max of profit. So here I think that this is clear. I had just initialized my minimum price with the integer max value. Why I need this? Because I want to store the minimum price of from my array. I am just iterating a for loop, and I'm just comparing. If any of the price is lesser than my minimum price, I'm just storing that. Okay, and then I am using this minimum price to find the maximum profit. And for the profit, what I'm doing, I'm just using my iteration of the loop, and then I am subtracting this with the minimum price, the minimum of it. So it will be always in future. So here it is a O of n complexity and O of 1 space complexity. That's it.